Show that an analytic function f of z equal to u plus iv is constant if its real part is constant, if its imaginary part is constant, its modulus is constant, its argument is constant. Let us prove the first part. Its real part is constant. So we have to prove analytic function is constant. Okay, that means f of z is analytic function. We have to prove this analytic function is constant. Okay, by assuming its real part is constant. You see, the first condition, if its real part is constant. If real part is constant, then we have to prove f of z itself is constant. So you should understand the question. Show that the analytic function f of z is constant. So what we are going to prove is f of z is constant. That's what we are going to prove. And what is given if its real part is constant. So let us consider u is constant. What is the real part of f of z? U is the real part. So u is constant. What is the derivative of constant function? 0. So dou u by dou x is 0, dou u by dou y is 0. Why? Because u is constant. Real part is u, right? U is constant. If you differentiate constant, it is 0. If you differentiate u with respect to x, it is constant. If you differentiate u with respect to y, again it is 0. Not constant, it is 0. Derivative of constant is 0. So dou u by dou x 0, dou u by dou y is 0. So now we will apply CR equation. Since the given function is analytic, dou u by dou x is equal to dou v by dou y, and dou u by dou y is minus dou v by dou x. So we know that ux equal to vy and uy is equal to minus vx. So just the equation has been interchanged, that's all. You can write the equation as it is, as you have learned. So you have learned it, ux equal to vy, right? Dou u by dou x is dou v by dou y, and you have learned uy is equal to va minus vx. So uy is equal to minus vx. So minus is here. Dou u by dou y minus dou u by dou y is dou v by dou x. This is nothing but CR equation. Okay, CR equation. Also, what about the previous step? Dou u by dou x and dou u by dou y are 0. So we substitute dou u by dou y is 0, dou u by dou x is 0. So this particular term is 0 and this particular term is 0. So from this we say dou v by dou x is 0, dou v by dou y is 0. Okay, since uy is 0 and ux is 0, Vx, using Cauchy-Riemann equation, Vx is equal to 0 and Vy is equal to 0. So, what is our conclusion? If Vx is 0, derivative of V is 0 means V is a constant function, right? Vy is equal to 0. Derivative of V is 0. Derivative of V is 0 means V is a constant function. V is constant. Therefore, V is constant. So already our assumption u is constant. Already what is given in the question? Given in the question, real part is constant. That is, u is constant. U is constant. We have proved that v is constant. If u and v are constant, f of z equal to u plus iv is also constant. Okay, since real part is constant, imaginary part is constant, u plus iv is also constant. So we say f of z is a constant function. So what's our question? Show that analytic function f of z is constant. So we have to prove f of z is constant by assuming its real part is constant. So we have proved f of z is constant by assuming u is constant. Similarly, you can prove b part, you can do it on your own. Okay, you can prove its imaginary part is by assuming v is constant. Imaginary part, right? V is constant. You can prove f of z is a constant function. That means you say v is constant, dou v by dou x 0, dou v by dou y 0. If dou v by dou x and dou v by dou y 0, you can write the Cauchy-Riemann equation, and there you can equate uy is 0 and dou u by dou x is 0. From that you will get u is a constant function. Therefore, f of z will be a constant function. So second part, this follows as in A. You can do it on your own. Now third case, its modulus is constant. Show that an analytic function is constant if its modulus is constant. So modulus of this function is constant. So here you see mod f of z. What is modulus f of z? Modulus u plus iv. Modulus u plus iv is root of u square plus v square is constant. This is our assumption. Okay, this is our assumption. Now that means root of u square plus v square can be assumed to some constant c square or u square plus v square equal to c. We can assume eliminating this root, we can assume root of u square plus v square is constant, means u square plus v square is also a constant. Okay, modulus is constant, that is our assumption that is given in the question. If square root of u square plus v square is constant, then u square plus v square is equal to c, where c is some constant. Now let us differentiate this with respect to x and y. So when you differentiate with respect to x, okay, u square plus v square equal to c square. So now let us differentiate this. Derivative differentiating partially with respect to x. Differentiate partially with respect to x, we get 2u dou u by dou x plus 2v dou v by dou x is equal to constant 0. Derivative of u square 2u. With respect to x, it is dou u by dou x. Derivative of v square is 2v. With respect to x, dou v by dou x. And this 2 can be eliminated, right? So this equation, in this equation, dividing by 2, this 2 can be eliminated. So we get u into dou u by dou x plus v into dou u by dou x is equal to 0. So now let us differentiate partially with respect to y. So with respect to y, same 2u dou u by dou y plus with respect to y 2v dou v by dou y is equal to 0. Also here also dividing by 2 will be eliminated. So we get this. Since f of z is analytic, it is given f of z is analytic, we get dou u by dou x is equal to dou u by dou y and dou v by dou y. Okay, ux equal to vy and uy is equal to dou u by dou y. Uy is equal to minus vx. Vx, okay, dou u by dou x is dou v by dou y and dou u by dou y is minus dou v by dou y. This is CR equation because the function is Cauchy-Riemann equations are true, right? Since the function is analytic. So I have taken this CR equation as equation number 1 and 2. Okay, equation number 1 and 2. So now this particular equation will become therefore, or this can be, I can give some number. Let me take this as a and this as b. Okay, therefore a implies u into dou u by dou x. You see dou v by dou x is, what is dou v by dou x from equation 2? Dou v by dou x is minus dou u by dou y. So I write minus v into okay, v, and what about this? Dou v by dou x is minus. So this plus becomes minus dou u by dou y. Dou u by dou y is equal to 0. This is because of 2, okay, by 2. So now you see here also you have u function, here also you have u function. Similarly, next equation dou v by dou y. What is dou v by dou y? Dou v by dou y is, you see, dou v by dou y is dou u by dou x. So we can, instead of dou v by dou y, we can substitute dou u by dou x. So that particular equation b implies u into dou u by dou y. Okay. So now this v can be changed to, what about this v function? Dou v by dou y. Dou v by dou y is dou u by dou x. So v into dou u by dou x is equal to 0. This is because of 1, okay, by 1. So now, okay, now we consider this particular equation. This particular equation can be taken as 3 and this particular equation can be taken as 4. Now 3 into u plus 4 into v, okay, implies 3 into u means this is equation 3, right? You multiply this by u, we get u into u square dou u by dou x minus this particular term into uv dou u by dou y. Then you have to add it, okay, plus 4 into v. So this is 4 into v uv dou u by dou y plus 4 into v, next term v square. V square dou u by dou x is equal to 0. So here we can eliminate the terms plus dou uv dou u by dou y minus uv dou u by dou y. So what remains? U square dou u by dou x plus v square dou u by dou x. So here this dou u by dou x can be taken as a common term. So what remains? U square plus v square. So you can write u square plus v square dou u by dou x is equal to 0. Okay, u square plus v square, common term dou u by dou x is equal to 0. This implies dou u by dou x is equal to, what is u square plus v square? It is a constant term, right? U square plus v square is constant, that is c square. So whenever you divide this by c square, 0 by u square plus v square, where u square plus v square is a constant term, c square, so this is 0. So dou u by dou x is equal to 0 implies u is constant, because derivative of constant is 0, right? Here dou u by dou x is 0 means dou u by dou x 0 means it implies u should be constant. Derivative of constant is 0. So we can assume that u is a constant function here. Okay, similarly we can prove. So in the same way we can prove v is constant. Similarly we can, so we are not proving this, just it's enough you write. Similarly we can prove v is constant. If u and v are constant, what is f of z? F of z is u plus iv, right? F of z is equal to u plus iv. Since u is constant and also v is constant, u plus iv is constant. Okay. Similarly we can prove v is constant. Therefore f of z equal to u plus iv is constant. Therefore f of z is constant. Therefore f of z is constant. Hence we have proved. Hence what's our question here? Hence we have proved this. That means if the modulus is constant, we have assumed f of z as a constant function. If modulus is constant, then the function itself is constant. Okay, that is f of z is constant. Now fourth case, what is the fourth question? Fourth question, if the argument is constant, right? Fourth question, if argument is constant, then the function is constant. Show that the analytic function is constant if it's argument. So we assume argument as constant here. Let me take the argument. Last argument f is equal to, so we know that argument of f of z is given by tan inverse of u by v. So it is given argument f of z is constant. What is argument f of z? Tan inverse of v by u. Okay. Argument f of z means tan inverse v by u. Therefore this is constant. If tan inverse v by u is constant, then v by u itself is constant. Therefore v by u is constant. Let us take this constant as k. Okay. Therefore v by u is equal to k. This implies, okay, so from this v is equal to ku. Now differentiate 1 with respect to x. Dou v by dou x is equal to k into dou u by dou x. Now you bring this to the denominator, so we get like this. Now differentiate 1 with respect to y. So when you differentiate dou v by dou y is equal to k into dou u by dou y. Now bring this to the denominator, we get like this. 2 and 3, RHS is equal, so we can equate the LHS. So equating LHS from 2 and 3, we get this equation. Now taking this denominator to the numerator, we get an equation like this. Now we take the CR equation, and instead of this dou v by dou x, we apply minus dou u by dou y. Okay. Also dou v by dou y. What is dou v by dou y? Dou u by dou x. We apply this dou u by dou x. Now dou u by dou x, dou u by dou y, dou u by dou y, dou u by dou y the whole square. Similarly here also dou u by dou x the whole square. Now we have a minus sign also here. Now taking this to the other side, minus will become plus. So dou square, dou u by dou x the whole square plus dou u by dou y the whole square is equal to 0. Since these two terms, adding these two terms we get 0. First term is equal to 0, second term is equal to 0. Since derivative is 0, we say u is a constant function. Therefore derivative is 0. u is constant, real part is constant, therefore f of z is constant. Okay. If real part is constant, then the